Hi, my name is Ansu Ko of Joseon University of Korea. This work was done with my collaborator Margaret McDonald from University of Wisconsin. Our study is about how infants might process input to learn language. More specifically, we investigate the mechanism by which reading might facilitate infants' word learning. We propose that the efficacy of book reading in infants' word learning is mediated by child-direct speech. Based on our findings, we suggest that social factors must be implemented to the AI for it to be more human-like.
AI can do many great things. When AlphaGo won Lee settle, some people are worried that the AI might colonize the planet and enslave its human inhabitants. However, when it comes to certain things like language, AI is not able to implement even the basic cognitive functions afforded to a baby. For example, an infant learns to establish the phoneme inventory of their native language by their first birthday. But AI is far behind the babies in such tasks. In this study, we investigate the mechanism of how an infant might learn language from the speech input and ask what we can learn from a baby to build a flexible, human-like AI. The starting point of our research is how book reading as an input might facilitate infants' word learning. There's a lot of literature attesting to the efficacy of book reading in children's language learning. Shared book reading is considered to support language learning due to the lexical diversity and the higher proportion of canonical and complex syntactic structures. However, most of the studies measuring the outcome of reading on word learning are focused on children who can already speak, so not much is known if reading is actually useful to pre-verbal infants. To our knowledge, ours is one of the first studies that actually directly measures the outcome of reading on pre-verbal infants based on eye tracking. So after addressing this question of whether or not reading is useful to pre-verbal infants, we move on to the question of what's the mechanism behind the efficacy of book reading for pre-verbal infants. A total of 31 infants participated in our study. In our longitudinal study, we measured the input variables when the babies were about 7 months old and measured outcome variables when they were 13 months old. Let me explain where they might have been in their linguistic development at each of these ages. English learning infants are known to be able to extract monosyllable words around 7.5 months old. So when they first participated in our study, our infants should have been busy working on segmenting words out of the speech stream. Also in English infants, it is known that infants can associate arbitrary labels of an object with its referent around when they are 14 months old. So when our infant participants returned for a test, they must have been working hard to master the word learning mechanism. We wanted to investigate the longitudinal effects of reading and the general language input on infants' word learning. So at 7 months, parents are asked how many times a week they read to their child, and we conducted a day-long recording of the child's home language environment by using the Lina device, which is a small recording device you can put in a pocket, and it records up to 16 hours of the child's home language environment. At 13 months, the infants were tested for word comprehension by intermodal preferential looking paradigm. Parents also completed the MCDI Korean, which is a traditional way of measuring receptive vocabulary by parental input. Let me explain a little bit about the word comprehension test that we administered using the intermodal preferential looking paradigm. It measures infants' language comprehension by comparing their looking time on two visual images presented side by side. We can take a look at the example of a trial of this test.
양말, 양말이다. 양말 저기 있네.
We tested the 40 picture Bertaggi words. They were selected from the MCDIK, rated as being understood on average by at least 40% of 13 to 14-month-old Korean babies. All images were yoked to another image. So for example, puppy always appears with a picture sack. This combination will appear twice, once with the puppy as the audio stimulus presented, and the ones with the sack as the audio stimulus presented. Therefore, each image appears once as the target and once as the distractor. Accuracy of word recognition was measured as a proportion of looks to target. The proportion of looks to the target image at 0.5 is a chance level. Therefore, a proportion of above 0.5 indicates that the baby is able to associate the sound with the image. We can visually examine the time course of looks to the target image during the first 2 seconds post-target word onset. We can find a tendency that more frequent weekly reading tends to have a higher proportion of target looking. When we constructed the mixed effect model, we found the effect of weekly reading frequency to be significant. So we found that reading at 7 months has an effect on word learning by 13 months. But reading occupies only a very small portion of daily activities. In our data, it accounted for only about 1% of the entire day or 4% of the entire words. We can therefore ask if reading has an effect on word recognition over and above those provided by frequent child-direct speech. Therefore, we conducted a mediation analysis to examine if CDS mediates the effect of reading on word recognition. For this mediation hypothesis to work, first, the effect of reading frequency on child-directed input must be significant. Second, the effect of child-directed input on word recognition must be significant. Third, the effect of reading frequency on word recognition must be significant, which we already confirmed. And importantly, the effect of reading frequency on word recognition must disappear when both the reading frequency and the CDS are included in the model. So now we need to analyze the language input. The LINA system provides an estimate of the adult word count, but does not differentiate the CDS from ADS. So there's no way of knowing how much of the adult word count is directed to the key child. But we need to know how much of the adult input is directly spoken to the child. So to have an estimate of the CDS word count, we manually coded each 1-minute segment. We listened to the speech and we identified who the speech was addressed to. We also identified segments including book reading to estimate the adult word count during the book reading activity. This is a graphical representation of the amount of CDS and ADS over the 16 hours in our participants. We can see that there's quite a bit of individual variation in the input pattern. The blue indicates the CDS amount and the orange indicates the ADS amount. Here is the result of running 4 mixed effects models to test the mediation hypothesis. We already saw the effect of reading on word recognition earlier. We additionally found a significant effect of reading on CDS and a significant effect of CDS on word recognition. Crucially, when both the reading frequency and the CDS were included in the model, reading lost significance. So we can conclude that the effect of reading on word recognition is completely mediated by the amount of CDS. Let's now think of the mechanism that might underlie the language benefits associated with reading to children. Book reading is known to involve the densest CDS word count in earlier research, and our present data also reflect this tendency. In our data set, of the average 83 words produced for 5-minute segments, 52, or over half, were child-directed. If we examine the number of child-direct speech in reading and non-reading contexts, we see that the reading ensures a substantially higher number of words in the input than in non-reading segments. Not only quantity, but also the lexical diversity in picture books may be an important source of vocabulary for young children. Therefore, it seems that book reading serves as a good vehicle for delivering child-direct speech both in quantity and quality, which in turn facilitates infant vocabulary building. But features of book reading, such as sustained focus on shared objects and the contingent responses are also available in high-quality child direct speech. In our data, there are many more non-reading segments than reading segments, and these include less dense CDS activities. However, even without reading, parents were able to reach a similarly high word count as they do during reading, despite the lower count on average. So what seems to be important is the social factors in the input. In other words, infants' learning mechanism seems to avoid meaningless calculations by focusing only on the signals embedded in social contexts. Here is how the social factors in CDS might support language learning. Cross-linguistically, infants show robust preference for CDS over ADS. The high pitch and the exaggerated intonation in CDS are likely to modulate the arousal and draw infants' attention to the communicative intents of the speakers. The heightened attention, in turn, could enhance infants' coding and the processing of the information in the input and induce effective learning. To summarize, when quality and quantity input is provided in social contexts, the infant is likely to attune to the communicative intents of the speakers and establish a joint attention. This heightened and shared attention seem to have provided enhanced segmentation cues for our pre-verbal participants and enhanced the uptake of word meanings. In contrast, if the input is provided without a social context, there's no such cues available. So infants do not seem to benefit from an input such as overheard speech or TV. Here's some take-home messages. Make sure to read your pre-verbal infants even if they don't seem to respond verbally yet, because infants seem to process input embedded in social contexts, and the more such input they get, the better they will be in word learning. Finally, we can ask how such social factors can be implemented in AI for it to work more human-like. We suggest that if we want to mimic infants' acquisition, there must be the ability to focus on relevant input and ignore the irrelevant. Also, input that occurs in a social environment should be used for learning more so than input from other environments. Thank you for listening to our talk. We thank the families who participated in our study and our faithful research assistants for helping with us to collect the data and coding them. This work was supported by the generous funds from the Ministry of Education of Korea and the IITP. Thank you.